Good morning. So this is a review of worksheet 201. And what we're going to do is we're going to go over questions 1, 9, 13, 14, 15, and 16. So if you want to pause the video and check out your answer form and see if you got those wrong or right. Also, while you're there, check out what other questions did you get wrong or right. So those are the ones that I'm going to go over. If you want me to go over anything else, please send me a video and or an email, and I'll gladly I'll send you an email or a quick video to go over any particular question you want to go over. Okay, so our first question is question number 1. Which statement most accurately describes the Earth's atmosphere? So what I like to do in these cases, I like to treat each option as a true or false. So we'll do that for each one. If you were to guess on this, if you were guessing a multiple choice, the chances of you getting it right are 1 out of 4. But if you guess on a true or false, your chances are 1 out of 50, or I'm sorry, 1 out of 2, 50%. So the idea here is just take each option and turn it into a true or false. And even if you have to guess on that one option, it'll help narrow it down a lot. All right, so we're going to take each option, A, B, C, and D, and we're going to treat it like a true or false. And if we have to guess, we guess, and we'll go from there. All right, the atmosphere's altitude is less than the depth of the ocean. All right, so what we want to do here is we want to go to the reference tables and compare. So the atmosphere's altitude is less than the depth of the ocean. So if you had done your 201 lab, let's preview that. So one of the things that you could do on your 201 lab was you were supposed to create little triangles for Mount Everest and for the Marianas Trench. Now, the Marianas Trench is the deepest part of the ocean at about 11 kilometers deep. So that little blue triangle right there, that represents the Marianas Trench, which also then represents the maximum depth of the ocean. Now, if you had done the lab, if you did the lab, you should have 4 layers to the lab. 4 layers include, on my example here, includes all 4 of these blue layers. So if that little tiny triangle represents the maximum depth of the ocean, and these 4 layers represent the maximum thickness of the atmosphere, then the ocean is definitely not as thick as the atmosphere. So going back to our questions, the atmosphere's altitude is less than the depth of the ocean. That is going to be false. So I'm going to just put a F there for false. The atmosphere is layered, with each layer possessing distinct characteristics. So if I go to the reference tables on page 14, these are the charts for the reference tables for the atmosphere right here on page 14. Here we go, right here. It says selected properties of the Earth's atmosphere. They are most definitely, there are different layers, all with their different properties. So for example, the troposphere, as you go up in the troposphere, it gets colder. It contains most of the water, and it has the higher pressure. Whereas in contrast, the thermosphere is way up at the top, and as you go up in the thermosphere, it gets warmer and warmer and warmer, and there is no water in the thermosphere. So each one of these 4 layers, the troposphere, the stratosphere, the mesosphere, and the thermosphere, each one of those is a different layer with its own properties. So going back to my question, that is going to be a true statement. All right, next one. The atmosphere is more dense than the hydrosphere, but less dense than the lithosphere. Okay, so let's think about that. The atmosphere is made up of gas. If we go back to one of our lessons about density in Unit 1, we know that gases are less dense than liquids, and liquids are less dense than solids, for the most part. So the fact that it's saying the atmosphere is more dense than the hydrosphere, that's saying that the gas is more dense than the oceans, which would make the oceans float on top of the atmosphere. So that's not a true statement. So that's false. The last one, the atmosphere is a shell of gases surrounding most of the Earth. All right, so I can understand how most people would see that and then go, hey, you know what, that's a true statement. The little trick there is the word most. The atmosphere is definitely a shell of gases, but it's definitely surrounding all of the Earth. And if we go back to our lab, when you drew in the layers for the atmosphere, those layers very clearly go around the entire Earth, not most of the Earth, but all of the Earth. So that last one is also going to be a false statement. So now that I've identified the only true statement, I'm going to choose answer B. All right, moving on to question number 9. Question number 9, according to Earth Science reference tables, as altitude increases from the troposphere or tropopause to the mesopause, the atmospheric temperature will do what? All right, so what we want to do is we want to treat these as a true or false again. And it's telling me I should go to the Earth Science reference tables, so that's what I want to do. I want to go to the Earth Science reference tables. I'm going to go to page 14, and I'm going to find the, what was it? The tropopause. So we're going to go from the tropopause to the mesopause. I need to read that carefully because there is the troposphere and then there's the tropopause. So it's asking us what happens when we go from here at the tropopause to not the mesosphere, but the mesopause. So this point right here. So if I follow along my graph line goes up to the right. And so if I look at the temperature here, as altitude increases in going from the tropopause up through the stratosphere, the temperature is going to increase. It's going to go from -55 to 15, or I'm sorry, to 0. But then it's going to go from 0 and it's going to dip back down to -90. So the behavior of the atmosphere, the behavior of the temperature between the tropopause and the mesopause is it's going to increase and then decrease. So going back to my question, increase only, that's a false statement. All right, increase and then decrease. Going from the tropopause, we saw it increase and then decrease. So that is a true statement. And then decrease, then increase. That was a false statement. And decrease only, that was also a false statement. So my answer, I want B. Question 13. Okay, question 13. If you did the lab, you may have picked up on this. The part of the lab is literally done specifically for this question. So which graph best represents the percentage by volume of the elements making up the Earth's hydrosphere? So the hydrosphere is talking about the Earth's water, both liquid and solid. And so what we want to do is we want to look up the percentage by volume. So what I want to do is I want to go to my reference tables. And I want to go to page 1, all the way at the beginning. And I have average chemical compositions of the Earth's crust, hydrosphere, and troposphere. So that's the table that I'm interested in. So going down to that. And what I want is I want the chemical composition of the Earth's hydrosphere. So I'm going to move this out of the way a little bit over there. All right, so the hydrosphere, it's 33% oxygen, 66% hydrogen, and 1% other. So if you think about this in terms of a pie chart, 33% is about 1/3. So if I do something like this, that's about 33% right there. And then 66% would be the rest of it. And those add up to being 99%. And then one little tiny bit, 1% would be literally this tiny little slice. That would be 1%. So we're looking for a pie graph that looks like that. So going back to my worksheet, what I'm looking for is option C. Okay, question 14. Question 14, which diagram best represents the Earth with the ocean depth drawn to scale? Okay, so going back to our lab, if you had gotten to the part where you were drawing in the Marianas Trench, again, there's the Marianas Trench right there. It's really, 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 really small. Even to the point when I start zooming in, it's still really, 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 really small. So I zoom in as much as I possibly can, and the Marianas Trench is this tiny little triangle. It doesn't even really make much of a dent into the lithosphere. But as soon as I start zooming out, that triangle almost disappears. As a matter of fact, it's gone. I can't see it anymore. And so now if I make my model the same size of what's on the worksheet, maybe about that big, Yeah, I can't see that little triangle of the Marianas Trench, and that represents the maximum depth of the ocean. The hydrosphere is so thin that on our model, we can't even put it on. When you do the math during the questions on the lab, you do the math, and it actually rounds down to 0. We can't actually put it on the model because we can't make something small enough to actually fit. So yeah, so the oceans are super, super, super thin compared to the rest of the Earth. So which of these diagrams would be the best? Well, it would really be the one at the bottom. It would be the answer D, because you really can't even show the oceans on this scale. All right, moving on to question 15. Solid rock material that directly underlies the sediment of the ocean floor is part of the Earth's what? So the key idea here is what they're saying here is the solid rock material that directly underlies the sediments of the ocean floor. So they're talking about the solid rock that is at the very outside of the Earth. So if I go to my notes and I look at my vocabulary, the lithosphere, the solid rocky surface of the Earth, and it includes the lithosphere, the asthenosphere, the stiffer mantle. Oh, that's not right. It includes, that should not include, interesting. I'm going to get rid of that part. It includes the crust and the plastic mantle. A little correction there in our notes. All right, so let's see where that definition is coming from. So let's go to the ESRTs, and we're going to go to page 10. There it is. So where we're talking about right here is the, it shouldn't be the plastic mantle, it should be the rigid mantle. So we're going to change that in the notes. So yeah, so the lithosphere is the outside rocky edge. It's that black line, and that's what the water would be sitting on. It's going to be sitting on top of the crust, which is part of the lithosphere. So going back to our notes, let's change that first. So it shouldn't include the notes. It should include, from the reference tables, it should include the rigid mantle. So we're going to put in there the rigid mantle. And a rigid obviously means stiff, rock-like. So hard rock, right? So includes the crust and the rigid mantle. All right, and then we're going to go back to our questions, and we're looking for the right answer. So the solid rock material that directly underlies the sediments of the ocean floor is going to be the lithosphere, and that's by definition from our notes. Question 16. Oxygen is the most abundant element by volume in which of the Earth's layers? So what I want to do is I want to go to the reference tables again, and I'm going to go to page 1. All right, and I want to go to the average chemical composition of the Earth's crust, hydrosphere, and troposphere. Get rid of this little pie chart right here. And we're looking for which layer is the oxygen most abundant in. So looking at the different layers of, we have the crust, we have the hydrosphere, we have the troposphere, and the question is specifically asking by volume. So I want to be looking at, my choices are 94, 33, or 21, because those are all volumes. So oxygen is the most common in the crust. So going back to my worksheet, we're looking for the crust. All right, so big thing on this lesson is using the pages in your reference tables. Page 1, the average chemical composition chart. Page 10, the inferred properties of the Earth's interior. And page 14, the selected properties of the Earth's atmosphere. So that was the big idea of this particular worksheet. If you have any other questions that you'd like me to go over, please feel free to email me, and I'll send you a quick description of what's going on in that question that you're asking about, or I'll put together a video for you. All right,